Good afternoon and welcome to Design Master Training. My name is David Robison. Today we're going to be looking at the various questions that have been sent in about our electrical software for AutoCAD. If you're attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. The first question that we have is a customer who's trying to set some wire sizes, and he wants to set the hot wires to 750 kcmil, and he couldn't find a way to do that through the software. So if you go into our dialogues, if you take a look at, like, say, a panel, and you go to the conductor amps, this is where you would set your wire size. So we're going to size the conductors based upon the overcurrent protection, the breakers based on the size of the panel. So basically we get a 100 amp wire. But you can choose a different size. And if you go down here to our larger sizes, you'll see that they actually stop at 600 kcmil. We don't have anything bigger than that listed here. And the customer specifically wanted a 750 wire. So what you need to do is go into the options, into the wire sizing. So if we go to customization and we go to the wire sizing command, here we have the list of all of our ampacities and the corresponding wire size. So we have 750 kcmil listed as an option in our wire sizes, but it's not actually used anywhere. So you can't actually assign it as a hot conductor. So you would need to come in here and make a change here to include the 750 kcmil. So we could take, I'm not really sure where that would even be appropriate, but say we could take this 400. We could take that 600 kcmil, and we could say, okay, for 400 amp wires, I actually want to use 750 kcmil. Select that. You do then also need to update your impedance values, the X and the R. Those are pulled from the table 9 from the NEC in the back. So you update those values based on the NEC so that you have the right impedances. Because we don't pull the impedances because it depends on the number and temperatures and other things. So just let you type that in. So you'd want to change the number here, the wire size here, change the impedances, and then when we go to when we go to a panel and we go to a feeder size, we now have that 750 option. So that's the way to get a wire size in there as a selectable option when we don't otherwise have it. The next questions relate to photometrics. Our photometrics originally our point-by-point photometrics in particular, were originally intended for outdoor photometrics. And over the years, they've evolved and been modified such that you can use them inside. However, you do need to be a little bit more careful inside with what you're doing. Maybe we would have designed it differently had we started intending them to be used by point inside, but we didn't. So they just have kind of historical features built in there. Some of them good, some of them bad. That's just the way the software works. So I'm going to define an area here and point out some areas where the customer is having some confusion. So if we draw an area, we'll now do we'll do calculations in this area. I'm actually going to make one change there. I'm going to do our grid spacing at 5 feet, so we just have a little bit more. The foot candle levels being calculated. And I've got these lights in here defined to use to do photometrics. Make sure I've got that set up still. Got an IES file associated with them. They need an elevation. They're set as general lights. So we do the calculation, and we get our foot candle levels for those lights. Now, what's not obvious is if we actually come here and say we want to do the calculations over here. I'm going to put in another area. Do, say, this stairwell here. Say you're doing the calculations for your whole building. So you're drawing out each of your rooms as separate areas. When we run our calculations, the light from this light fixture is actually going to spill over into this room. And so you'll see that these lights here, if you query them, there's no IES file. They're not set as general light. So the only lights that are being used are these ones here. But we're actually still getting light in this other room. And so that ends up causing confusion for a lot of people. And what's happening is so basically, if a light is not in the area, the light still casts into that area. So you need to make sure when you're working indoors, if you're basically defining your rooms as areas, you need to check this area has walls checkbox. And when you do that, then we'll define all of these edges of the area as an actual wall, and then we'll block the light. So if we check that box, that area now has a wall. So this line here is going to be treated as a wall, so we won't cast the light through it. So now we run our calculations, and then we have 0 foot candles happening over here. There's still some foot candles coming from somewhere else. I probably got another light defined somewhere that has something going in there, but it's not coming off of these walls anymore. Oh, actually, my wall, I think, is lower than my fixtures I put up at 10 feet, and my wall is at 8. So obviously you want to get that right, because that's a big space. So we'll say we'll take our wall up to 20 feet. Now we appropriately get 0 light over here, and all our light is just in this room. So when you're working indoors, you need to make sure that your boundaries, you have them set to have walls so that they block the light. When you're outdoors, there are various reasons why you would want light to go into a different area, even though the light isn't in that area. And so you don't actually want them set up as walls. So you have to have the option, and you have to set things up, get your model set correctly. Then there's also the question, when you insert the light fixtures, you can have the contours being displayed. So if I click OK and I insert this light fixture, it's just going to come in, and we don't have any light being cast. Part of the reason is because it's not actually set up with an elevation. So if I put this at 10 feet, specify that it's going to be a general light for doing our photometric calculations, now it's going to come in, and it's going to have the spread for the contours for that light being defined and shown there. So if you want those contours, you have to have it set up as an IES, set up as a fixture for calculations. You have to have an IES file. You have to have lumen set right, and then it'll show up. You also have to have your contours turned on. So the contours that we display are the same ones that are specified here. So if you don't have any contours specified, or you have contours, say we had just a 10-foot candle contour and everything else is 0. If we now go and insert a light fixture, we still have a contour, but it's just that one contour because that's the only contour we have defined. So if you want to have more contours, you need to define them in your calculations, either here, or this is also available through options. So you can come into options and set those values as well. This way you can also set it for new projects. And now it comes in with all those contours. And you'll notice that this light fixture and the IES file are actually not really in sync. I grabbed a random IES file for this demonstration, and it's kind of wonky relative to that. Just to complete it, you probably want to have that IES file rotated to match your fixture. So if you have a case where the fixture and the IES file don't match, that's handled in the light fixture schedule. So if I pull up the light fixture project schedule, we have the option here to rotate it. And it rotates it counterclockwise. And I think we'll rotate it 90 degrees. The next question was a customer. He had a warehouse, and he had a number of suites in it. That they're going to have a kind of a similar setup. Actually, he sent a picture that he agreed that I could use. Like this. He's kind of got a meter center here, and then he had a couple suites that are going to be typical. They're going to have a panel, a step-down transformer, and then a couple panels connected to it. And he wanted to know how to best model that. In particular, could he do it with recurring panels? You can, with a little bit of work on your part. We don't have any way to model this directly, because our recurring panels really assume a single panel, not a recurring group of panels. So you can't define 3 panels in a recurring transformer and have those recur as a group. So instead, what I recommended was that he model a single panel, basically model this whole thing once as a typical, using standard panels and transformers. And so that way you can get the load on panel HA. Then create a recurring panel template and have the loads on that, using fixed loads, match what your calculated value was for that typical. So you'll have to transfer the loads over manually. That's a manual step, unfortunately. And then you can insert that recurring panel as instances in various spots in the project. So instead of, you're not inserting all 4 of them, you're inserting just the first panel in the group with the corresponding loads, and then you have that kind of called out somewhere else. So the way you would do that, so you would want to define a panel, and then he had a transformer, and then he had another panel downstream of that. So we got our pieces modeled there. Now we can connect them to each other. Then you can go down and you can set your loads at LA. I'm just going to put in a lighting load. And we can insert our schedules. A lot of steps you always have to do to get everything modeled properly. But once it is modeled properly, so the loads from LA is transferring up to HA. Then you would create the recurring panel template. And what you'd want to do is in the template, you need to then copy those loads over. So we go to our circuiting, and we've got our template, and we just want this to match. So we'll make this a 3-pole breaker, and we'll say transformer, and it's got 10 kVA of lighting. Now obviously it might have more loads, so you fill in the rest of the loads that go in there. And then we insert instances for each of those. So we have HA1, and then you can either create it in the database or you can actually insert them on the drawing if you want to, depending on what you want to do. And say those are all fed from a switchboard. And then we can do our connections, and so we can take all of those instances and connect them to the switchboard. And that would be the best way to model it. It's not going to be a perfect exact modeling. Again, when you make changes to the suites, you have to remember to update the template manually, so that's a manual step. But once you've done that, then each of the template's going to impact the instances, and you'll have a good load calc. Update that, have it update the loads, and we'll have the load for 3 panels. Next question the customer asked. He wanted to know, is there any way he can change the insertion point of circuit tags on the drawing? So when you go and circuit a device, we insert a tag for it. So I come over here, I've got some light fixtures. These are all currently circuited. I'll put some new ones in. And when we circuit them, it puts in this call out here. And the direct answer to his question is no. There's no way you can change where that goes. It just kind of goes in the bottom right. We do our best to make it look decent. The assumption is that probably you're going to go draw home runs and loops, and they're going to disappear anyway. But if they're going to stay, it can be a little tedious to move them all manually, one at a time. So you can't control where they come in originally, but you can move one of them and get it looking how you want. So say we want it here at the top. Then you can use the match command to get all the others to look the same. So we have the match note values and locations. Select that first one is the good example. Take these other ones, and it'll put them in the same spot. So that works for all notes that we have. So any note that you have, you can get one looking good and then run the match and select the other ones and get all those labels in the same spot. So we can't get a good default, but we can hopefully make it a little easier to move them after the fact. All right, our next question. There's a customer who had 2 seemingly similar looking circuits. And one was coming in as a number 10 wire, and the other was coming in as a number 12. And he was trying to figure out what the difference there was. And the answer is in the options. So if you ever have a number 12 and a number 10, you're trying to figure out what's going on, it's always going to be this setting in the options. And it is the upsize number 12 to number 10 wire length. So basically, we have an option in there that if your number 12s exceed a circuit in length, you can just automatically have the software upsize them to number 10, assuming that for voltage drop purposes, you need to upsize that wire. Currently set to 75 feet, so if you're 75 feet or more from the panel, we're going to upsize that wire. Then we have the option on the home run, whether you want to show a number 10 on that home run or not to indicate that it's been upsized. So everywhere else, we'll call it out as number 10. like on the voltage drop schedule or in a feeder schedule, always listed as the number 10. But for the home run itself, we have the option to show it as number 10 or not. So to demonstrate that, the distance to the farthest fixture is 167 feet, so we're definitely over our number 10. Our 75 feet, so we're going to have number 10. So currently we're not showing our number 10 wire there. So it's just showing normal tick marks with the assumption that's number 12. Probably in the spec you say somewhere, hey, if it's over 75 feet, you should upsize it to number 10. So the contractor just knows to do that. Alternatively, you can go into options and you can say, yeah, I want to show that when we upsize it. So we'll set this to yes. It puts in the number 10. So it doesn't put the full wire call out. The tick marks are kind of filling in for all of that. But we do the number 10 saying, hey, this one is upsized. This should be number 10 just based on distance. And so if you see that happening, that's what's going on. It's pulling it from that option based upon your distances. Next question is again about modeling some distribution equipment. He sent in this picture. It's an existing condition. The panel open here is the one that he was specifically concerned about. So he's got this panel with some breakers up top, and then down below there were a number of just large breakers, not really on the odd even side. They're kind of just in line there. And so the question was, how should he best model that? And the answer is, we don't have any sort of distribution equipment that looks exactly like this. So when you have something like this, you kind of have to build it up with pieces based upon what matches in our software what you've got. So my recommendation was you probably want a 4-circuit switchboard, actually probably a 3-circuit switchboard with some bottom lugs. So you have these 3 breakers, and then a regular panel that you would do a connection to a feed-through connection to that switchboard on, and that kind of gets everything put together properly. So looking at that in AutoCAD, it would look something like this. And it's going to have 3 positions, and it's going to have feed-through lugs. And so now we can do those 3 breakers that it has, and then we've got the panel that's up above it, and however many poles it has. It didn't look like it was actually a full 42, say it's only got 20 circuits there. And then we'll connect them together. Connect actually the top is going to connect to the bottom on the feed-through lugs. So now they're connected. And then in the one-line diagram, you kind of have to draw it out. You probably would put those 2 pieces together on the one line so that they look nice. Because if you do just the standard generate, it's just going to draw something like that. You probably would actually want to flip that whole thing around and whatnot. So there's a little bit of drafting work that you'd want to go through to make that look how you want. In fact, that one would probably be easier to draw manually rather than having the software generate it. So if you come in here and say, okay, let's put in the bottom piece first, you can have it use a default, or maybe we'll just draw it as a custom box. You got the top piece here. You do want to line things up a little nicer, and then we got our connection. And then if anything else was feeding from those, they would connect to the right bus from there. Now, so that's how I'd go about modeling something like that, where our software, we don't have that specific configuration, particularly in existing configurations. They're just, there's a lot of different ways you can build panels, a lot of different stuff out there, and we can't build it all in so that we have a button for each type of panel you might run into. But we have enough pieces that you should be able to put it together to get something that models correctly that you can then use for your design. A question that we actually get quite frequently is that someone has a design, they're looking at their light fixture schedule, and they've got a quantity count or something that doesn't match what they think should be in the project. So we insert our light fixture project schedule. We'll actually turn on our quantities they're on. So we come over here, and this is our schedule, and we look at this F1 and say, oh, there's 2 of them. I don't think there's any on my project. And so the customer says, I'll often say, hey, where are these light fixtures coming from? The software is seeing 2. I don't think there's any, and there shouldn't be any because I don't want them in my project. Where are they? And so we actually built a command specifically to answer that. You can use it for other purposes as well. It's the Project Explorer. I always go to the pull down for it for some reason. It's here on the ribbon, so it's there. run that command, and from here, now you can track down your stuff. So this is sorted by callout and then by drawing. So it was a F1 that we were looking at. And we can say, oh, hey, it's actually on this other floor, on this other drawing. If you expand it, it'll just kind of list each one with just an ID. And if you click find, it'll go to that drawing and say, hey, here it is. So if you can't find it, it'll just show you where it is. And if you want to kind of browse through them, you can use next and go to look at the next one. So we've got next and previous. And then once you have one selected, you can do Q for query and it'll actually pull it up. So if you're looking at like a receptacle that's got an interesting load or a piece of equipment, you can just pull it up and start making your changes there. Equipment is a little different because it's not always going to be on a drawing, and that's another place you can lose things. So the equipment on this project all has been inserted. But if we go in and we create a new piece of equipment, and we're going to create this one in just the database. So now we have this piece of equipment, and if we insert an equipment schedule, so we've got this one that's inserted, but it's not actually anywhere. It's not anywhere in the project. And so when you have that happen and you run the Project Explorer, if you go look at the equipment, it will list equipment that's not inserted on a drawing. If you click find, it's not going to do anything because it's not on a drawing. There's nowhere to find it. You can click query and you can pull it up and you can make your changes. If you want to get rid of it, and this is just an equipment thing at this point, but to get rid of the equipment, you run the delete equipment from database. So this is the command to take something that's in the database and just get rid of it, because you can't erase it from the drawing because it's not on the drawing. So you can run that, select it, and then click delete. And now it's gone. So that's if you got a piece of equipment hanging out there you need to get rid of. That's how you get rid of it. And that is it for questions for today that I had. Does anyone have any other questions that they'd like me to address? So we do have a question there. So the question that we have is, how do you connect loads from two different drawings in the software? And the answer to that is that our software looks at a project as everything in a single folder. So if we go into Windows Explorer, in your project folder, you have the database file, which is the .dm file. So this is where all our information lives, and there's one database file for an entire project. And then you've got multiple DWG files. So we've got multiple floors of lighting, and we've got the panel schedules on a separate drawing. And so the way you get it to work is you just make sure all of those drawings are in the same folder, and then you connect them, as there's really nothing to be done at that point other than to connect them. So here we've got our second floor lighting, and we can run our circuiting, and all of the panels in the project are available. You just choose what you want to connect it to. So that LA panel that we just created, we could put some of those light fixtures on here. So those are now connected to that LA panel. So we've got stuff on this drawing and on the other drawing, both connected to panel LA. Actually, this is just a fixed load, but we could go back here and we could put some other stuff on it, or I could even open up another drawing. Let's take a power drawing. Take my first floor power, put some of these receptacles on that panel, circuit those receptacles. So now we've got second floor lighting, first floor receptacles. Probably not how you'd actually design it. And then we can go to another drawing. We can go to our panel schedule drawing, entirely different drawing. And we can insert the equipment here, or the schedule here. So all of those loads from those other drawings are being displayed on this drawing. So as long as all the drawings are in the same folder, they're using the same database. And you can have multiple people working on a project in separate drawings. So obviously you can't have multiple people in one drawing, but AutoCAD enforces that. But you can have multiple people working in different drawings. So if you have one person working on power, they can be circuiting, one person working on lighting and circuiting, and that works just fine. The database allows them to share as long as you got on a shared network folder. Another question from the comments. Can I go over the best way to model modular furniture for an office? For example, you've got 320 volt circuits on a 3-pole circuit breaker. So the way most people handle that, going over to my power drawing, is they typically model it as a receptacle. So we'll go into our receptacle, go to our project schedule, and we'll call this our modular furniture. And you need a block. You probably don't want to use a receptacle. You could just use a J-box. That's kind of like our default catch-all symbol that you can use. Or you could draw something else that looks a better representation, whatever you want it to be. I'm going to just choose the J-box. Then you specify each load, and each of these loads can be on a separate circuit. So you have your 3 separate loads for this modular furniture. Now we've got our 3 loads that we can have. Save that. We can insert that on the drawing now. Take our modular furniture receptacle. You can also override the loads on the individual receptacles because each receptacle could have a different thing plugged into it. So you can override it here, but if they're all the same, you just want to define it in the schedule. And then you drop one in each place you've got that furniture. And now for your circuiting, you'll want a 3-pole breaker. And we can use the circuit to phase command to connect it to the individual phases. So we run the circuit to phase. We've got the A, B, and C. We'll put on the A phase, select that the modular furniture. We'll put load 1 on phase A, click OK. So you press enter. When you're doing circuit to phase, you get an option to increment to the next circuit or to set the phase. So I can choose to set the phase. I'll go to phase B, and then I'll select that device again, put that on load 2, enter, set phase, phase C. And it thinks it's a receptacle, and we've got a little trigger in there saying, hey, do you have too many receptacles? And it says yes. That's just based on the loading. So it's giving us this warning. There we go. So now we got A, B, and C, load 1, 2, 3. And it shows up on the panel schedule looking like that. And then if you want to have this on the next one on another circuit, you do the same thing. So, but you do that, and you can build up your modular furniture that way. Then when you draw the home run, you have options for how you draw that as well. When you do the draw home run command, it will prompt you. Actually, it's going to do all 3 circuits. I thought it would give you the option for separate circuits. Yeah. Okay. So it's going to give you 1 home run because that's a single circuit that's going back to. If you actually had that defined as multiple circuits, so if these were 3 single pole circuits, you could getting it looking like this if you wanted it to. But that does require those to be separate breakers. If it's a single breaker, we assume it's going to be combined, and you get a single home run. And you get the shared neutral as well, because it's all going back to the same circuit. Next question from the comments: if you have a drawing where you need 2 separate scales, say an 1/8 inch and a 1/4 inch, is it possible to have 2 scales on one drawing? And the answer to that is no. You can't have 2 scales on a single drawing. There are various ways you can try and fake it. I'm not even going to show them to you or tell you about them because it will not work. And eventually at some point you'll do something and everything's going to switch to one scale or the other, and then you'll be sad because half your drawing is no longer the right scale. So don't try and do 2 scales on one drawing. You want to do the drawings, separate drawings. So then there's a follow-up question. What if you want to XREF one drawing into the other? And the answer to that is yes, using standard AutoCAD functionality. When you're working on the drawing in model space, you need to have your scale set right and everything working out. But you can then XREF them into other drawings without any problem. So our software doesn't do anything special in terms of how you could XREF it into another drawing. So you could be working on this drawing, or actually you probably have your 1/8 scale drawing, your 1/4 scale drawing, and then your actual plotting drawing where you've XREF'd them both in, and that works just fine, just using standard AutoCAD XREF functionality. So nothing special there in terms of XREFing them in. You'll obviously only be able to work on the original drawing. The XREF will just be a display view of it. So there's an additional question. How do you change the tick marks on the wires? And so there's 2 different ways I could interpret that question. How do you just change what the block looks like, or how do you change what tick marks are showing up? So if you just want to change the blocks themselves, if you use a different looking symbol, that is under options. It's got its own section, tick mark blocks. So you've got the blocks and then spacings that you can specify. I will change my neutral block from the long. I'm going to change it to an X. So now our neutral block is going to use a different graphic. And now we have that X block. And you probably, so you can see why you would want to adjust your spacing. That controls how far apart they are. So those are getting a little tight, kind of squished. So maybe we set this to 0.6. Now it's got a little more space. All right, so that's how you can change the graphics. There's a couple other things you could do with tick marks. There's also the question, well, what if you want different, just if that's not the actual configuration of wires? And the answer to that is you got to go back to your model and get it set up so that you do have the right configuration of wires. For example, say there's no ground on this. You would need to come back here, modify this receptacle, and remove the ground wire, because we're including a ground because it was specified to have one. And if you don't want a ground, you got to get that ground out of there. Actually, we always include a ground, even if the devices are ungrounded. I forgot, we actually always include ground, because generally speaking, you always want a ground. Even if the fixture doesn't, even if we just always include one. So if you don't want to ground, the other place, again, to set the tick marks, there's lots of places to change things. You can come in here, and you can turn the ground wire off here. So you could set here to say, okay, there's actually no ground on this wire at all for this circuit. You could, if you wanted to get rid of your neutral, the neutral is actually required, so you can't get rid of that. But this is where you can get rid of the ground. Then someone's also prompting that you can also go into the wire customization and make a different wire size there as well. So there's lots of different ways you can do this. So now there's no ground wire there. You have to redraw the home run. Actually, it depends. You actually don't have to. In this case, it actually didn't. So here, if I come here and I put the ground wire back on, it actually updates automatically. Just if you're changing the blocks themselves, do you need to redraw them or run a coordinate drawing in database to get a chance to update things? There are a number of other options for tick marks, I believe under home runs. How you have your tick marks arranged, if you want your hot tick mark first or your neutral first. So you can switch it to have the neutrals in front, and where the ground goes in the front or the back of the tick marks. So I'll switch it to be in the back. And for this one, you do have to redraw. The assumption with those options is that basically you have those set right at the beginning of your project, and then you're not changing them during the course of a project. So now I've got our neutral in front, ground and back, so that if you do change them, it's a little bit of work to get them updated. I believe we can test this. If we run a coordinate, it might update them. So if you go and you make some changes to your options, you kind of want to run a coordinate at that point. And you can see the coordinate takes a little bit of time because there's a lot of stuff to check and to update. So generally, you don't want that happening too frequently, or unless you actually specifically request it. So you make your changes, get it looking right, and then run the coordinate. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.